Let's take a look at negative exponents. We have some basic illustrations here, some examples in the middle section, and then just for some additional variety, I'll look at some problems on the back side of this handout. Here we're starting off with the simplest of them all. Here's the base, there's the exponent, and it's negative. Think of it like a fraction. We always want to reformat it so that we have positive exponents. You check every single base, and if it has a negative exponent, you move it across the division bar so that it will then become a base with a positive exponent. Now in this case, the numerator seems to be empty. Put a 1 there as a placeholder. In the second case, you can see now we have the situation where the base is in the denominator, so that will be moving across the division bar. And when we do that, it is now a positive exponent. Now, notice when you do that, the base does not change sign. It doesn't go from a positive a to a negative a, or from a negative a to a positive a. No, the base stays the same. The only sign that changes is the sign on the exponent. Of course, you don't have to have that denominator of 1, so you could just simplify it as a to the x. Here in this third case, check every single base. So here I have a base with a negative exponent, so that will move. Here I have a base of b with a negative exponent, that's going to move. It looks like it's being flipped upside down, but the idea is that each base is being relocated independently and positioned with a positive exponent. Okay, what if you have a combination of both negative exponents and positive exponents? Here I have an a to the negative x times b to the y. That's a positive y. All that is divided by a to the positive x and b to the negative y. So again, you check for each base independently, one at a time, and if it has a positive exponent, it stays where it is. If it has a negative exponent, that base is going to move. So let's reposition those two. So we end up with a numerator that has this existing b to the y, and then this b is being moved up to the top, so that'll be another b to the y. Here we have an a to the negative x that is being positioned underneath the division bar, now with a positive exponent. And here we have an existing a to the x that's already there, okay? So now all the exponents are positive, and what we're going to do is simplify by multiplying those bases together. So remember, when you multiply bases, you add those powers. So 1y plus 1y is 2y. And same with the x's. 1x plus 1x is 2x, and there's the result. So let's look at a variety of illustrations here. Problem number 1, again, set that up as a fraction. Check your base, and you can see that's the only base we're dealing with. So we're going to move that across the division bar, and so that becomes 1 over x cubed. Here in problem number 2, here's our only base. Move that across the division bar, and so we end up with a squared. Here in problem number 3, again, set them up as a fraction if you don't have a fraction already. Check each base independently and just move those that have a negative exponent. So the y has a positive exponent of 6, that will stay there. So y to the 6th remains in the numerator, x now to the positive 4 is what we have in the denominator. Here on number 4, my base is 4. With the negative exponents, we're going to reposition it at the top, and so now it's 4 to the power of positive 2. So 16 is our result there. Here in problem number 5, we check each base, and we move it independently of the other. Again, here it looks like they're just being flipped upside down, but you have y to the 4th over x cubed. Here's number 6. Now think for a moment about what we have with the number 5 and 10. What is its exponent? Right? You look right here and there's nothing there. That means it's that invisible exponent of 1. That's a positive 1. So 5 will stay where it is, 10 will stay where it is, but the base of a has to move because it has a negative exponent. The base of b has to move. The base of c has to move. So all of those are going to relocate. So that means we have 5 over 10 staying where they are. The a moves down, so that's an a squared. The b moves down, that's b cubed. The c moves up, so that becomes c to the 4th. Now we can simplify the fraction here, so let's turn that into a 1/2. And since that fraction is 1/2, I'm just not putting the 1 in front of the c to the 4th. That's just my coefficient of 1, and there's the half. Here in problem number 7, again, check each base to see which has the negative exponent and move that along. So the b squared is already a positive exponent of 2, so that stays where it is. Move the a to the bottom, that becomes a with a positive 3. Now, don't leave that numerator blank, put in that placeholder of 1. Take a look at number 8 here. This is interesting because we have now a negative exponent that is wrapped around a base of 3y. There's a couple ways we could approach this, and one way to do that is to apply that negative exponent to the entire collection. And in other words, move the whole thing under the division bar. So that means we have 3y still wrapped in parentheses, but now it has a positive exponent of 3. We can't let it stop there. We want to raise each power to the power of 3. So 3 has a power of 1. Y has a power of 1. Let's raise each power to the power of 3. So we have 3 to the power of 1 times 3, so that's 3 cubed. And y to the power of 1 times 3. And then simplify 3 cubed, and that's how we'll end up with 27. All right, here's number 9. Taking a look at this one. Again, we're going to raise each power to the power of 1. You can see that this whole fraction is wrapped in parentheses. The whole thing has the negative exponent. That means it applies to both the top and the bottom. So you can think of it like 3 to the negative 1 over 4 to the negative 1. And then we'll move each base independently. So we end up with 4 over 3. All right, jump over to a problem like number 12. There's a lot going on here, so I want to take a look at this one, and let's see what we have, because there's lots of parentheses, lots of variables. Let's see what we can do. Now, there are a variety of steps that we could take. There's a variety of sequences of steps, so this is just one way to approach the problem. And what I'm doing is I'm observing where I have my positive and negative exponents. Notice that the 4 has a positive exponent of 1. X has a negative exponent, so I have to move that. Y has a negative exponent, so I have to move that as well. And this is a little bit of a curious feature. Here in the denominator, we have a 2x wrapped in parentheses. That whole thing is being raised to a negative exponent of 6, a negative 6. So that entire grouping is going to be relocated. And then here we have another negative exponent. So I'm going to shuffle these around first, and then I'll simplify after that. Okay, let's see what we have. So notice that this 4 stays on the top because that had a positive exponent. This x to the negative 2 is going to be moved to the bottom. So there's my x with a positive 2. This y to the 4th, excuse me, y to the negative 4th will be moved to the bottom as y to the positive 4th. This bundle of 2x is going to be moved to the top. Keep it wrapped in parentheses because the entire thing is being raised to the power of positive 6 now. And lastly, this y to the negative 8th moves to the top as well with a positive 8. So what I'm looking at doing next is right here. I want to apply the power to the power rule to raise the 2x to the power of 6. All right, so we still have the 4 in front. Now we have 2 to the power of 6. We have x to the power of 6. And then y to the 8th, all in the numerator. That's being divided by x squared. And y to the 4th. So I'm going to use my calculator here to figure out what 4 times 2 to the power of 6 is. That gives me 256. And now we have all of our exponents positive, but this is not fully simplified. We now want to recognize that, hey, we're dividing a common base. We have x being divided by x. So that means we're going to subtract those exponents. So we have x to the power of 6 minus 2, which gives us 4. And in the same way, we have y divided by y. So we have to subtract those exponents as well. So we have y to the 8th minus 4. So that's y to the 4th. You'll notice then that there's nothing left in the denominator because those just divided away. So we'll just put a 1 right there. And that's our answer. 256, x to the 4th, y to the 4th. So let me take you to the back side as there's a few other problem types that aren't represented here in this note section. So if you'll flip over to the back side, take a look at this section in the middle of the page where we have the section starting off with number 1 and sort of working way down here. Notice that here it says evaluate. So that gives us a clue. What that means is we're going to do a substitution. We're going to plug 2 in for A. and 3 and for b, and then when we simplify it, we will get a numerical result. We'll get a number for an answer. That's what evaluate means. So let's take a look at some of these. Let's start with 32. So step 1 is to do the substitution. So there's the coefficient of 3. Plug in the 2 for the a, so there's my 2 squared. Plug in the 3 for the b, and there's my 3 to the power of negative 1. All right, so set that up as a fraction. Find your bases with the negative exponent, relocate them. So we end up with 3 times 4 on the top, and 3 to the power of 1 in the denominator, and those cancel out. So there's our evaluated answer, right? So evaluate means you'll get a numerical answer. Take a look at the next row down here. I want to show you both 35 and 36, and that's because they're formatted so similarly. They look almost the same, but notice our order of operations will be different. They both have an a being added to a b, right? But here, each term has its own negative exponent. As opposed to in number 36, each term has a positive exponent, but the entire binomial is being raised to a negative exponent. And those means very different things, and you have to watch out. Because up to this point, when we've been moving bases with negative exponents, notice that the operation was always multiplication, right? It's 3 times the a squared times the b, right? All of these are being multiplied. The previous problems have been multiplied. So when you get to a problem with addition, the rules are a little bit different. You have to think of your order of operations, and you have to be careful here. So let's contrast these two side by side. Again, we're going to evaluate means we'll do a substitution. Let's plug in negative 1 for a and negative 2 for b. So in number 35, I have a base of a to the power of negative 1. So here's my substitution, plugging in the value of a, and then raising that to the exponent of negative 1. There's a plus sign. Plugging in the value of b, which they tell us is negative 2, and that is also the negative 1 exponent. So what that means is each of these are independent terms, and each base has to be moved across its own division bar. So here you have a result of 1 over negative 1. And we'll add that with 1 over negative 2. So remember, the sign on the base doesn't change. It's just the sign on the exponent that changes. So now that exponent is a positive 1. So we have to add a negative 1 with a negative 1/2. So that's a negative 1½ You can think of it as negative 3/2. What we're doing here is we're creating a common denominator of 2. So we have negative 2/2 combined with a negative 1/2. That's how we get the negative 3/2. So there's your result. So contrast that with what happens in number 36, where we're wrapping the parentheses around the binomial. Okay, let's do our substitution. So we have a value of a, which is negative 1. We're adding that with the value of b, which is negative 2. All of that is being raised to the power of negative 1. Okay, if you think of your order of operations, you have to do the operation inside the parentheses first, right? We didn't have parentheses over here, so we weren't combining them first. We combined them last. But in number 36, we have to combine these bases first, because that's our order of operations. So negative 1 combined with the negative 2 gives us a result of negative 3. Then we do the exponent. So now we're going to move this across its division bar. Now again, the sign on the base stays the same, so it's still a negative 3, but now it's a positive 1 exponent, and the numerator needs a placeholder of 1. So in other words, it's a negative 1/3. And with that, our examples are done.